Does anybody else want to go for him? I'll take that as a no. Alright.
Mr. King, do another hero Friday for us.
I've already done like 3.
Alright, I'm gonna do it.
Did my dad, I did Coach Colvin.
Who's Coach Colvin? Oh, I remember that guy. I remember that guy.
I thought he was talking about like downstairs electrical.
Chris Colvin was my high school cross country coach, and I definitely did talk about it.
I thought you were talking about Colvin.
Yeah.
I would have never thought that.
Yep. Ran cross country. I was pretty decent.
Oh, really?
I was like my 5K average was under a 5:30. Like sub 18 minutes on a 5K. Huh? Say it again. Say it louder. For most of high school, yes, but I weighed like 60 pounds less. I am 5'8".
Alright, hit. Come on, Buffalo.
So, getting started with today. What? No. We're about to start. We can talk about this later. So, thank you. What's your question, Amy? A place called Lamp Magnet Program. Alright. So, really quickly, I don't even know what your questions are asking to one. Because this question came up in first block, I do want to, and I assume it probably comes up here for some of us. Don't forget, the reason why I assign new groups every day, and the reason why I'm getting frustrated by some of us choosing to switch, and I'm starting to pay attention to that more, is because, one, different people have different understandings of the mathematics. And so by generating new and random groups, I am letting you work with new people to learn ideas from each other. If you just stayed with the same people, you would keep mostly the same knowledge within that group, and those ideas would not get shared. So I generate new groups every day so that you can learn from new people, so that you can learn more in general. So that's why I need y'all going to the groups that I generate so that you can get those ideas flowing around the room. The second reason I do it is, you know what you're going to have to do for the rest of your life? Talk with people, talk with new people, get to converse with new people. So I'm trying to help you develop a skill while also distributing that knowledge around the room. So please make sure you go to the groups you're supposed to. Today we are working on complex numbers. We're going to mostly start with adding, subtracting, and multiplying. We're doing a quick recap of what I mean by, well, we actually haven't actually talked about complex numbers yet. I'll explain that in a second. We're going to do a recap of imaginary numbers and then solve some equations with imaginary roots, learn how to graph imaginary numbers, whole 9. So this is what we started with yesterday, is the back side of that proficiency scale, the complex coordinate system and imaginary solutions. We do need to know how to simplify square roots. We need to classify numbers of the real number system. So we're going to talk some more about those number systems today. We did talk about some of them yesterday. When I say natural, what type of numbers am I referring to?
1, 2, 3, 4, 5, 6, 7, 8.
1 to everything past it. Now, when you say 1 to everything past it, does that include 1.5?
No. I said 5, 6, 7.
So it's only the positive. Now be careful, the whole numbers has its own set. What's special about the whole numbers?
Oh, they got 0. 0, that's 0.
0. So remember, be careful, the whole number set is 0, 1, 2, 3, 4, etc. The natural numbers, though, are the 1, 2, 3, 4, 5, 6, 7, etc. Those are my natural numbers. Okay? What did we mean by integers?
Negative and positive included.
I like the way you said that. Negative numbers included. So all the numbers we just said and the negatives, so those numbers and, does anyone know an O word? What? The opposites, right? So 1 and its opposite, -1, 2 and -2, 3 and -3. Those are my integers. And all of those are classified under the real numbers. We've already talked a little bit about rational and irrational. We'll continue with that today, and we're going to talk a whole lot about the number I. We're going to extend all that into this target section today of adding, subtracting, multiplying imaginary numbers, and these things. Listen, legitimately, we're gonna finish this up today and maybe beginning of Monday. On Monday, we are going to do a demonstrate your understanding, some review.
What's up?
I don't got much.
It's gonna be great from the last one.
So there will be some overlap so that yes, you can show me improved understanding. Back up, hold up. I need to remind y'all, because I know some of you are like, Mr. Keeney, that's too quick. However, back up. One, I just want to let y'all I want to give you some perspective. I hear what you're saying, but I'm going to give you some perspective. I was talking to one of my students from last year who has Miss Beasley. They have a quiz every other day. Legitimately, back up. I'm just saying, I want to give you some perspective. Once every 4 or 5 days, 3 or 4 days is not that much. 2, remember, I pushed back that last demonstrate your understanding 2 days for y'all, which is why we have this second one as quick as we do. Okay? So, we are going to have plenty of practice, but we got to learn these things. Alright. Now, we got into this sheet yesterday, the imaginary friends. And remember, we got to D here, and we ran into a problem. What was the problem we ran into with D? So x squared is equal to -9. What's the problem with that? Well, in the form it is right now. So be careful. One, we're not squaring a negative. I can square a negative, but what is -3 squared? 9. So I can't square a number and get a what? Now I need to clarify this. I cannot square a real number. So can't square a real number and get a negative. Because remember, this is what we talked about yesterday. A positive times a positive is always what? Positive. What's a negative times a negative? Always positive. So no real number that we knew of could I square and get a negative, which is why mathematicians defined what? Okay, so remember, they actually didn't define I. They defined I. They defined I squared. Where I squared was what? -1. So remember, they defined I squared so that I squared is -1. And I know someone's still like, Mr. Kinney, that's a variable, that's a letter. It's not a letter, it's a what?
Imaginary number.
It's a number. You can just say number. We're going to talk, and I will say I is an imaginary number, yes. But more importantly, it's a number. I know it's a letter there, but remember we talked about it yesterday. There's Euler's number, that's an E. Right? That's a number. There's the letter pi, but that's a number. When numbers are super important in math, we name them with a letter, okay? So it is the number what? Number I, okay?
Yep.
So remember, we defined I squared so that it's -1. Cameron, do you want to turn around so you can engage in the learning process? So what was I, right? So we defined I squared so there was -1, so what was I?
Square root.
Not cube root,
-1.
square root of -1, right? Remember, it's just, hey, if you take the square root of both sides, you get I, and you get square root of -1. So remember, we defined it such that I squared is -1, so that we can square a number and get a negative, but that means that I is the square root of -1. That's it. When you see square root of -1, you need to think
Oh,
I, and when you see I, you need to think
square root of -1.
it's a number. Keep that in mind. And remember, the beauty of that was now, when I take 3i and I square it, what's 3i times 3i? 3 times 3 is 9. I times I is I squared, but I squared is I squared is -1. So, now I have a number so that when I square it, I can get a negative. Guys, I told you at the end of class this yesterday, I'm going to tell you this again. Every year I ask, why is I important? And I'm telling you right here and right now, I is important because now I can square a number and get a negative. And every year, people miss that question. I even tell them, I'm going to ask you this question. Why is I important? I is important because if I square it, I can get a negative.
Yes.
Or don't write it down. I don't care.
We're almost there, guys.
Yes, you can put it on the back side where it asks about notes. I'll wait a second for you to write down what notes you need to. After that, I need you to get out page 93, lesson 6 from the textbook. Yes, Maddie. Huh? It's on, or 93.
Wait, what is as if we're not trying to
Because now I can square. Alright, look, we talked about this a second ago. We pointed this out where 3i squared is negative 9, right? So that number makes this equation true. Is there any other number that could make this equation true?
Negative one.
What?
Negative one.
Negative what?
1.
Close, but remember if it's negative 3 squared, that's negative 3 times negative 3, which is a positive 9.
Yeah. Oh. 3.
Negative 9.
Negative 9.
Wait, what you asking? Can what make
My
what?
question is, we know 3i makes this equation true because 3i squared is negative 9. So my question is there any other number that could make this equation true?
No.
Regular one.
Plus minus.
Someone got close just a second ago.
Negative 3.
Alright, right here. Let's come back to this and let's look at this. What could I do to solve this equation?
Square root.
Yo, this is a quadratic, so what do I need to do?
Square root.
Square root, right? So what would x equal based on this equation?
X equals negative 9.
Negative 3.
Off what equation?
Plus minus.
Okay, so first off, hey, we got part of it, positive and negative. But I need y'all to look at this again. Remember, I taught y'all how to simplify radicals once upon a time because I knew it was going to come up here, and I want us to pay attention to this. What are two factors that I could split negative 9 up into so that I have a perfect square?
3 and 1.
Are either of those perfect
3
squares?
and 3. Oh.
6.
2 times 3 is 9?
What?
You can't get that out now. 1 point, 3 points on. I don't know if we can get it.
Alright, here's my perfect squares. Are either of those a factor of negative 9?
9.
Oh, say it again.
9.
9, thank you.
We did kind of say 9 30 minutes ago.
We said it like 45
We
times.
definitely did.
45 is an exaggeration, you fool of it.
Me and her kept saying 9 and
9 times what gives me negative 9?
3.
1.
9 times 1.
3. Negative
9
1.
times
Negative 1.
Negative 1.
Like that.
Okay. Why would I want it written as this? What can I do at this point?
But then if you do that, you got to square root 9. When you get square root negative 9, right?
So, well, remember I can rewrite this using how many radicals? I can write it as 2 radicals. What are the 2 radicals that I would have? Square root of 9 and square root of?
Negative 1.
Guys, the reason why I would want to rewrite this as 9 times negative 1 is because I can rewrite it with however many factors I have as separate radicals. What's the square root of 9? 3. What's the square root of negative 1?
I.
Quiet.
When I see square root of negative 1, I need to think. Say it louder, Chris. I.
What? I said that, Mr. Kenny.
But I need y'all to notice, that means I have a positive negative 3i. So it's not just 3i, it's also,
Plus or minus. We didn't say that?
no one ever said negative 3i. What is that?
You.
Oh, that's from the syllabus that I did? It's from the syllabus. Okay. So negative 3i squared. That would have been the other solution because what's negative 3 times negative 3?
Negative
9.
9.
And what's I times I? And so that is negative 9. Please remember, we talked about this yesterday. Fundamental theorem of algebra. Every quadratic is going to have how many roots?
2.
2, right? Every quadratic is going to have 2 roots. So if it has a positive 3i, it also needs a negative 3i. Don't forget that when you take the square root, you get how many roots? 2. A positive
And a negative.
and a negative.
Yes.
Please do not forget that. We're going to apply all this information. Now, I need us to look at page 95 in the textbook. And this is going to tackle one of the target ideas on the proficiency scale from the other proficiency scale.
Actually.
Number next.
Okay.
Oh.
Now, did we look at this page at all yesterday?
Yeah, we did,
Yes.
but yeah.
Okay.
We were right on that graph part.
We were looking at the graph part. That's what I thought.
Both of those, yeah.
We did. Okay. So, I want to point this out. Okay. Looking at page 95, we have this work from Elena and Mark did something wrong, but I'm going to just focus on Elena's work here. So Elena subtracted 1 from both sides, then took a square root, and so she got x equals what for her solutions?
X equals plus or minus square root negative.
I need something else other than square root of negative 1.
I.
There we go. She got imaginary solutions or imaginary roots. I need us to look at this graph. Say again.
Is she like schizophrenic?
No.
The good old schizo.
Preston. Isn't everything we've been talking about dealing with the number I?
I think everybody's schizophrenic.
Hey, Miss Skinny.
I need us to look at this graph really quickly.
Miss Skinny, is next a number?
What?
Is next a number?
It's next to you.
Right here.
Hey, where
Looking at this graph, how do we know that the zeros are imaginary? Because what? I said looking at the graph. You're 100% right. I look at that equation. I look at the solutions here. Yeah, those are imaginary roots. How do I know this just looking at the graph? There's what? Remember, in the past, my zeros were the what? So in the past, zeros were always what? X-intercepts. But if there aren't X-intercepts, do the zeros just go away? Do the roots just go away?
No.
No, because there still has to be how many?
2.
There still has to be 2. So if there are no X-intercepts, then what do we know about those zeros?
They're imaginary. Ooh, what is it? She should guess it.
Say she was busy.
No, I was listening. This time.
Shoosh.
Guys, it's that simple. That is one of the easiest target ideas to hit. If you recognize there are no X-intercepts, there's still roots, they're just what?
Imaginary.
Imaginary.
Matthew taught me that.
Good. That's why I assigned that assignment.
Psych.
Matthew.
Now, that actually is, if you go in and do the Matthew assignment, it's there. All of those ideas to help you practice. It would help you more, J. Mike, if you actually wrote it on some
I
notes.
know.
But you know, like,
I'm just.
I can have ideas. Like, you know, like on the bathroom, it was like, when you gotta set these things all the or somebody don't.
The domain and range.
Yeah.
You need the video that I recorded last Friday where I taught you all how to do it?
What? Yeah, I was trying to get some watches on that. But see, my phone wanna watch this video. Cause I mean, I was sitting in the class listening to that same thing that you're saying, so now I'm learning it.
sometimes going back and refreshing yourself as I explicitly taught you. I will say this. I think I might have done a better job explaining a couple things in my first block if you want to watch the first block video from Friday. I didn't ask.
Tell your age. Like,
What the frick is throwing stuff?
Well, I made some explicitly for imaginary numbers. Would you rather me just not give you any for imaginary numbers? I'm not slowing down.
What? I'm crazy to say nothing crazy.
But remember, if my graph looks like this,
Yes.
my graph looks like this, what are my zeros for this blue function? Negative 4 and 2, right? I can see my zeros when they're real on the graph. Can I see the zeros and know what they are if they're imaginary?
No.
No. So please note that I can tell that it has imaginary, but I don't know what it is. Okay? And so that brings me to this set. So we're going to skip a little bit. We're going to come back to the problems in a few minutes. But I want us to look at page 106. So skip ahead to 106. Skip ahead to page 106. Or at least one person per group have page 106.
106?
I ain't got it
right there. Right there. Ditto.
So, this page 106, it tells us to graph those three functions. And so I went ahead and did it right here so you can clearly see it. What do the zeros or the solutions of those three functions all have in common? So looking at those three graphs, I want you to talk with your group for 60 seconds, and I want y'all to just think about, come up with an idea of what do the zeros of these three functions have in common? There is something about those zeros that all three functions have in common. So just 60 seconds. Push up. Are those zeros? What do the zeros have in common? That might be something important. Any ideas what those zeros have in common?
Now I'm pulling up my purple.
They are zeros.
I mean, there's always zeros, but like, what do these zeros have in common?
Well,
Any ideas?
They're imaginary.
This page.
Phenomenal.
No.
Phenomenal work.
All right. Jamie, what did y'all talk about? Did y'all come up with anything for the zeros? What are y'all thinking?
yeah, man.
Chelsea, why are they saying that it might be imaginary zeros? Okay, why can't, how do we know we can't see the zeros? Like, what are y'all leaving off detail-wise that
You don't see nothing intersecting with the
we
x-axis.
don't see it intersecting the x-axis, right? So, and Patty was like, I don't see any zeros. And I'm like, yeah, that might be part of it, right? If we can't see the zeros, they have to be what? Imaginary. So noticing those details can immediately tell us a lot. And I will point this out. What form of a quadratic is g of x in?
Vertex.
That's vertex form, isn't it? What would the vertex of that function be?
AX minus 8.
No, what is the vertex?
Oh, okay.
-2 and 1.
So wait, is it?
Anybody want to add on to explaining why or push back on that vertex?
The reason why is because the vertex is h and k.
Okay, so the vertex is h and k. Mel, it looks like you're trying to push back on that sum. Why is it a positive 2?
Oh, you got to switch your sign.
Yeah,
Switch your sign, yeah.
Notice every time we have those parentheses, it is the opposite. Okay, so the vertex is 2, 1, and the parabola is concave. So notice 2, 1, and concave up.
I swear don't.
So looking at that vertex form, knowing that it's above the x-axis, knowing that it's concave up, even if I didn't have technology, I could know that those roots are imaginary.
For real?
This is why it's important to understand those forms of a quadratic. In a similar way, when I look at f of x here, you can see that as a standard form, but also, how many times do I see my variable?
2.
One.
Oh,
Once.
I didn't see it.
So that could also be a vertex form. Notice how it has a vertex of 0, 9 and is concave up. So those zeros are going to have to be imaginary. We're going to talk some more about h of x when we get back, but I need us to recognize these details. Okay? Okay. I'm going to quickly do this note here because we already did this actually. Hey guys, if I want the zeros, what do I need to do for this function?
Make it equal to 0.
Okay, make it equal 0. Then what would I do? What is the easiest path to solve this one?
9 minus 9.
Minus 9, right? Is the type of vertex. So we actually already did this one. Negative 9 is equal to x squared. What do I now need to do?
Square root.
And we did this earlier. It's not just I, because remember there's that 9 there as well.
Yeah.
What squared gives me 9?
3i.
Okay, you're close. So positive and
Negative and positive.
so there's my zeros there. All I did was use my inverses. When we come back, we're going to move into number 4 and find the solutions for number 4. Really quickly, can you just
Shut up, bro.
this several days off. I want to push it. Working through this right here, all right? Pretty good work, right? So first off, why is everybody using inverses around the room? Like what tells us to use inverse
We in
operations?
vertex.
The vertex form, right? How many
Yeah.
times do I see that variable?
Once.
Only once, okay? So we're using those inverses to undo things. Now, when I look right here, great job, square root of a square, that gives me an I. Now, they end up with the right answer, but what am I going to push back on right here? Do not forget, it's when we take a square root that we do the plus or minus. Go ahead and show that there, right, Macaria?
Yes.
Okay? So, please also show the next step. What's the next thing that I can do here? Yes, what's the next step to solve this equation?
Is it still squared? Oh no, it's not. Inverse.
Okay,
Plus 2.
plus 2. Woo! Guys. Okay.
Oh, I'm sorry.
Now, I need y'all to pay attention to this. Okay, so I'm just going to write it like this for now. And I need y'all to hear me on this. What type of number is this right here?
Imaginary.
We go with the fact that this is imaginary.
Yes.
Okay? So this is known as the imaginary part. And what's the opposite of imaginary?
Real. Real.
Real.
Counting.
This 2 right here, does it have an I?
No.
No. Okay? So we're going to call this the real part. Now be careful. I need you, notice how I said imaginary part and real part? Because if I say this, how many numbers do I have right there?
1.
That is only one number, and I need you all to hear me clearly on that. 2 plus I is one number, okay? It just has a real part and it has an imaginary part. And so these are my 2 roots, okay? And so there's a real part there, an imaginary part there, and that's it, I'm done. I know some groups are trying to put those numbers together, but I want you to think about it. Can the real and the imaginary go together? Are they like terms?
No.
No. So what's it got to stay? 2 plus I and 2 minus I. That's it. So we stop there. Now, I want to look at a couple of things around the room, and I know most of us have the right ideas, so I want to be careful. So, Dewan, cameraman, help me out here.
Got you,
Right
brother.
here. I want us to be careful. Right here, what does this actually say? X
X minus
Minus
2
2
equals 2 plus a negative I.
plus or minus I. But is X minus 2 equal to 2 plus or minus I?
No.
No. Be careful, because what we would do next from here is add 2, and now I get different values, right? That is not the same,
Yes.
so we don't want that. Does that make sense?
Yes, sir.
You good with that? Okay. So be careful about doing that. Make sure you show your inverses so that error does not happen. And that brings me to a second error that I want us to learn from over here. So be careful. Okay? By not showing the inverse here, man, why y'all so scared of a camera?
I'm not. I'll turn my ring camera.
Oh, sure. So right here, I want y'all to notice the square root of -1 is not equal to the square root of x minus 2. Well, didn't we say up to this point that x minus 2 was equal to I?
Yes.
This is why we need to show our inverse. Right here, when I take the square root, doesn't that cancel out the square? So we shouldn't be showing a square root after that point. The square root and the square should have canceled, right, Jaquel? What did I say?
You said square root something.
Yeah. See, this is why we don't play around when Mr. Kenny's teaching. Maddie, focus. Okay? Focus. So, the square root and the square are canceling out. And so when I write my next step to this equation, there should not be the square root there. It should just be x minus 2. Now also, as soon as I see this, I'm not going to write the square root of -1 anymore. Because what is the square root of -1? So go ahead and rewrite it. But what's missing?
Negative
It's
off.
x plus 2.
Hey,
I mean, no, plus 2. Wait, oh, plus or minus.
But yeah, plus or minus.
Because we can add 2 next, but you got to have that positive and negative I in there. All right, what are your questions about solving this quadratic up to this point?
Nothing, sir.
We comfy?
For sure. Yeah, it makes sense.
Okay.
Brand new couch.
Now, I want us to work on 5A right here. Skip B. I'll talk about B later. Oh, that's what I actually want to do. I need everybody to go grab a calculator. Everybody needs a calculator in hand. I need my desk or calculator real quick. So, everybody needs a calculator in hand. So, and we said x equals 2 plus or minus I. So, 2 plus I should do what to this equation right here?
Make it true.
It should make that equation true, right? That's the whole point of a solution, is that it makes our equation true. Guys, that's a concept that's on the proficiency scale. You got to make sure you can show this. Now, that means I'm going to take the time to substitute that number in and check this equation. Now, start, and I want us to get practice with this, start by typing in your parentheses. And what's going to go inside of those parentheses?
X minus 2.
But remember, we just found the solution, right?
Oh.
So what is x? 2 plus, and not just any old imaginary, the number I. Okay, so I need y'all to hear me on this. There are letters on the bottom of your calculator. That is not where you want to find the number I. If you look here, where it has the pi symbol, right? So there's the letter H, right next to it is the pi symbol. Click on the pi symbol, and what do you see right there? There's the imaginary number I. So hit that pi symbol, go to I. So 2 plus I, now I type in the rest of the equation. So minus 2 squared plus 1 needs to equal what? What does that equal? 0.
0.
So 2 plus I minus 2 squared plus 1 is equal to 0. And what does it say? True? There's a truth. Now, I want to remind you, one of the reasons why I love these calculators is I can hit the up arrow, highlight that, because what other number should make this equation true? 2 plus I and 2 minus I. And guess what it's going to tell me? True. Okay? So I want to make sure we understand this. Take the time to check your solutions. Solutions should always make that equation true.
How you just copy and paste that right there?
If you hit the up arrow, go on, until it is highlighted in blue like that,
Yep.
and you just hit enter, it brings it down.
Tight.
Okay? Just like that. Alright, so I want to point this out, because we could have realized this pretty quickly without even having to use the calculator this time. Because what's 2 minus 2? 0. So I'm left with I squared plus 1 is equal to 0. And what is I squared again?
Imaginary.
Not just,
We get to a point.
it is negative 1. Remember, we defined I squared as negative 1 so that negative 1 plus 1 is equal to 0. Right? So remember, we defined I squared as negative 1, and that made I the square root of negative 1. But this is actually what we started with. We started with defining that number I so that I squared was negative 1. That's what we started with. Okay? Now, I want us to get a little bit more practice. And we're going to do that right here with number 5, but with C and D. Okay? I need to point this out to you with C and D. With 5C and D, this is on page 107, can I use inverses this time around? You just randomly guessing now? Okay, so I want to emphasize, I need y'all to pay attention to this. Dwan, Amber, right here. Right here.
Yes.
How many times do I see my x in this equation? I see it twice. So can I use inverses to solve this equation?
No.
Again, is it in vertex form? No, so I'm not using inverses. It's in standard form, so what should we probably use? Quadratic formula. I need you to make sure you work with everyone in your group to first write out the quadratic formula and then work on substituting things into that equation and doing it correctly. So let's get up, let's start solving this equation, please. Say again. It's not hard though. There's a formula that you have to memorize.
Natalie, no.
Couple of things. Most of us are finally starting to substitute our stuff in pretty well. There's a couple of details I need us to pay attention to. So, Bakari, I need you to focus here first. Maddie, you're making some small mistakes. I need you to pay attention over here first. Okay? Now, what I'm looking at here first, I just want to emphasize and remind you, this division bar goes across below the numerator, right? Have you ever seen me extend it below the x equals?
No.
And this almost looks like x equals just this. So, small details, but they matter. Make sure it's x equals, and it's just underneath that. Now, we're substituting things in well, but y'all are making mistakes when it comes to just figuring out what the radicand is. Hey, Bakari, really quickly, right here, okay? Once you write this out, first, make sure you put parentheses around the b squared. That's causing a lot of us trouble. Those of us who are getting negative 10, it's because you did not put this inside of parentheses. Next, make your life easy, and what are you going to type into the calculator?
The whole thing.
Not the whole equation.
The radicand.
The radicand. So remember, just type the radicand into the calculator. Because you could do this by hand, but I need us to know what's negative 2 times negative 2? Positive 4. There's a minus here. What's 4 times 1?
1. I mean 4, I'm sure.
4 times 2.
8.
So we should be taking the square root of negative 4. If you're not getting negative 4, it's because you're not paying attention to the signs. And you're trying to do it piece by piece. Guys, if you type this into the calculator, guess what? It's going to do it right. Type it into the calculator. Type that radicand into the calculator. Say it with me. Type that radicand into the calculator. Don't make your life hard. Type it into the calculator. Now, this is really why I needed y'all's attention though. Because we're forgetting what to do with that square root of negative 4. First off, because I'm taking the square root of negative, some of us are going, hey, I can't do that, Mr. Kinney. And you used to not be able to, but you can now. Because what type of number is this? It's going to be imaginary. We see the square root of a negative.
My bad, I had it's on the board about that.
all the way up. I can come collect it if I need to. Alright, listen. When we are trying to work with a square root, rewrite it as factors of that are what?
Bodies.
Starts with a P. Perfect squares. Thank you. Okay. What's a factor here that's a perfect square? 4. 4 times what gives me negative 4? Negative 1. And I'll say this. If you're trying to simplify a square root with a negative, you always want the negative 1. Because remember, how many radicals can I split this into? 2. The square root of? Not negative 4. Of 4 times the square root of? Remember, the beauty is I can take that one radicand. Am I boring you, Tyler? Is that why you got to talk to Jaquel?
Yeah. No route.
I've asked y'all multiple times not to be next to each other. Jaquel, can you? Huh? Multiple times I've asked you not to be next to each other because you distract each other. Like, y'all want to get bent out of shape when I'm correcting you, but it's not like I'm writing you up. It's not like I'm yelling at you. It's not like I'm kicking you out of the classroom. I'm trying to correct you so that you can learn. You can fix yourself in the beginning and then I don't have to say anything. So, what's the square root of 4? 2. And what's the square root of negative 1? That's what we should have here, okay? So, we get 2 plus or minus, what did the square root of negative 4 become? 2i. And I'm dividing everything by 2. And so I would ask that you simplify this. Notice I'm distributing my division. What's 2 divided by 2? 1. That's it. 1 plus or minus I. That's it. What are your questions about solving this quadratic?
We're not having
5.
What? Okay. So guys, don't forget, when you got a standard form, just use your quadratic formula and use the calculator to your advantage. But don't forget, you have to know how to simplify that square root. You do. Alright, at this point, no, we ain't going home. You guys have time.
Yeah, we
Alright, so, I need you to go back to your desk for a little bit. So go back to your desk to wrap us up today. And I need you to do the check your understanding questions because these are the check your understanding questions I did give you. Classifying numbers. There are no, right? So that's all of this. There are none of these on Mathia. I already got Kamaya's note to send her and Deanna to the next thing on Mathia, but there's no practice with this there. First things first, when we say natural numbers, what do I mean?
Normal numbers.
1, 2, 3, 4, 5, etc. Whole numbers. 0, 1, 2, 3, 4, etc. Integers. Negatives and positives. Well, the whole numbers and their opposites. Now, this is where I need to pick up really quickly. Rational numbers. We've talked about this a little bit in class. When I say rational, what do you already know? What do we talk about with the decimal? There's one of two things. It could either
Constantly keep going.
it either terminates or it repeats. Terminator, Arnold Schwarzenegger, he ends people's lives.
What?
Terminates, it ends.
Terminate.
Okay, so, guys, a rational number either terminates or it repeats. Now,
Write it down.
Oh, I'm not quite done here. Because I want you to see this word right here. What is the, hey guys, what's the stem of that word right there?
Ratio.
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 I want you to note that 1.5 can be written as 3 halves. Bakari, what are you doing?
When the
Yeah, drop it.
all varsity football players.
What's the attitude?
So.
Hey guys,
Them boys don't play golf.
please listen. Guys, Dewan. 3 halves. That's a ratio of integers. Even negative 1.3, I could write that as negative 4 divided by 3. A rational number is a ratio of integers. So if it's a ratio of integers, it's a rational number. If it's irrational, what did that prefix ir mean?
No, I mean.
Not?
Yeah, not.
So it's not rational. These are most of my square roots of non-perfect squares, right? Those are not going to terminate or repeat. Hey guys, to be a real number, that means it does not have what? Wait, Nick, there is no I. If it's an imaginary, what does it have? And all of my reals and all of my imaginaries together are called the complex number system. Please do to check your understanding. We will not spend a lot of time on this on Monday. No. This is to check your understanding that I gave you. This is a prayer model sheet.
And that's all with Mr. Kenny Entertainment.